Hello, this is a video on my multivariable calculus. In this video, we're going to go over exam 2 from spring of 2024. The first problem is approximate this quantity. So what we're going to do is we're going to start from a function f of xy equals the square root of x cubed plus y cubed, and also a point close to 2.01, 0.98, that the value of this function is easy to evaluate. Clearly f of 2, 1 is a good one, so that would be square root of 8 plus 1, which is 3. Next, we're going to differentiate this one, so that would be 1 half x cubed plus y cubed to the power of negative 1 half times 3x squared. Then we're going to have to plug in the values of 2 and 1 for x and y. So this would be 1 half x cubed is 8, y cubed is 1 to the power of negative 1 half times 3 times 4. So this is going to be equal to 1 half, this is 1/3, and then times 12. So this is 12 over 6, which is 2. Let's look at f sub y. F sub y would be 1 half x cubed plus y cubed to the power of negative 1 half times 3y squared. We'll plug in 2 comma 1 for f sub y to see what we get. So we would get 1 half 8 plus 1 to the power of negative 1 half, which is 1/3 times 3 times 1 squared. So that's 1/3. It cancels with 3. We get 1 half. So now we can approximate f of 2.01.98. I believe that's the number that they gave us. Okay, so this is going to be approximately f of 2 comma 1, which we evaluated as 3. So I'm going to put it down here, plus f sub x, which is 2, times x, which is 2.01, minus 2, plus f sub y times x minus x naught. And they asked us to simplify our answer, so we'll have to simplify this. So this would be 3, 2.01 minus 2, that's 0.01, times 2, that's 0.2, and then minus, so this would be minus 0.02, divided by 2, that's 0.01. So in fact, f of 2.01.98 is approximately 3.01. So that's an approximation for the given function. Okay, so the next question is, the next part of the same problem is find the direction as a unit vector in which this function decreases most rapidly at 0, 1. What is the minimum directional derivative? So in order to find the minimum directional derivative and the direction, we'll have to find the gradient. So let's find the gradient of this function x squared y plus y squared e to the x. The x component is 2xy plus y squared e to the x. The y component is x squared plus 2y e to the x. At 0, 1, we will get, so we'll plug in 0 for x and 1 for y, we get 1, 0 for x and 1 for y, we get 1, 2. So what is the direction? The direction is negative gradient, negative 1, 2, divided by magnitude of this, which is 1 plus 4, root 1 plus 4. That is negative 1 over root 5 and negative 2 over root 5. So this is the direction. And what is the minimum directional derivative? It is the minus magnitude of gradient. So the minimum directional derivative is minus square root of 5. It's minus magnitude of gradient, which we already found. Consider this function. We want to evaluate the limit or show the limit does not exist. Anytime we are trying to find the limit, what we do is first we're going to approach the point from different path to that point, and we compare those limits. So let's just start y equals mx. Y equals mx is a line through the origin, and there's also one more line which is x equals 0 that we have to also plug in. So if you plug in y equals mx, we get m to the 6, x to the 6 divided by m to the 4th plus, I'm sorry, x to the fourth plus m to the 6 x to the 6. So we can simplify x to the fourth. We get 1 plus m to the 6 x squared m to the 6 x squared. So this would approach 0 over 1 plus 0, which is 0, as x approaches 0. So it looks like the limit is 0, but we haven't tried the vertical line of x equals 0, so we'll try x equals 0. We will get y to the 6 over 0 to the fourth plus y to the 6. So that would give us 1. So now because these two numbers are different, so since 0 and 1 are different, the limit does not exist. Okay, so let's look at the second part of this problem. This part is asking us to find partial of this function with respect to v if x is u plus v squared and y is u minus v. So we have a function f that is in terms of x and y, x is in terms of u and v, and y is in terms of u and v. So what is the partial of f with respect to v? It is partial of f with respect to x times partial of x with respect to v plus partial of f with respect to y times partial of y with respect to v. So we have two paths from here to v, from f to v. We will evaluate each one of them and plug it in, and then they also told us that the answer could be in terms of u, v, x, y, so we don't actually need to simplify after that. So let's find the partial of f with respect to x. Partial of f with respect to x, we'll have to use the chain rule. So it would be y to the 6 over x to the fourth plus y to the 6 squared, and there's a negative sign. And then we'll have to multiply by 4x cubed. So that's partial of f with respect to x. Then multiplied by partial of x with respect to v, which is 2v, plus partial of f with respect to y. So derivative of numerator is 6y to the fifth times the denominator minus derivative of denominator times the numerator over x to the fourth plus y to the sixth squared. That's the derivative with respect to y. Times the derivative of this with respect to v, y with respect to v, which is negative 1. So this is our answer to this problem, and they didn't ask us to simplify, and they said you could leave it as a function of x, y, u, v. So let's move on to the next one. The next problem is asking us to find all critical points of this function. So to find critical points, we'll have to set f sub x and f sub y equals 0 and solve the system. So taking the derivative with respect to x, we get minus 2x minus 4y. Taking the derivative with respect to y, we get minus 4x plus 3y squared. The first one equals 0 gives us x equals 2y. We'll take that and plug it into the second one. We get minus 4 times 2y plus 3y squared equals 0. So we'll factor y, we get y minus 8 plus 3y equals 0. That tells us y is 0 or y is 8 over 3. Now if y is 0, we get x equals double that, which is 0 and 16 over 3. So we have two critical points. The critical points must be written in pairs. So there are two critical points. The critical points are 0, 0 and 16 over 3, 8 over 3. These are the two critical points. Okay, so next we're gonna look at the next part of the problem. The next part of the problem is asking us to determine if each critical point is a local maximum, a local minimum, or a saddle point. So what we're gonna have to do is to look at D and evaluate that determinant and then see whether it is positive, negative, and use the second partials test. So let me write down what I'm using here. We will use the second partials test. So let's find the derivative of fx. Derivative of fx would be 2 with respect to x. Derivative of fx with respect to y would be negative 4. If you take the derivative of this one with respect to y, we get negative 4. Derivative of fy with respect to y is 6y. And this is, of course, also fyx. Fyy is 6y. As we have the second derivative with respect to y is 6y. Now we'll evaluate d. So d would be 2 6y minus 4 minus 4. This is going to be 12y minus 16. Now we will plug in the points that we found in the previous part. So this would be negative 16. That's negative. So that means 0, 0 is a saddle point. Next, we're going to plug in the point that we found, 16 over 3, 8 over 3. I believe that's what we had before. Yes, and we will get 12 times y, which is 8 over 3, minus 16. So we're going to simplify this. 4, that is 32 minus 16. So that's positive. We cannot say it is the minimum or maximum without checking f sub xx. F sub xx is 2, which is also positive. So these two tell us that 16 over 3, 8 over 3 is a local minimum. Okay, let's look at the next problem. Using Lagrange multipliers method, find the minimum and maximum distance from the point 5, 0 to the points on the ellipse, and assume that this minimum and maximum values exist. Okay, so what is the distance formula? Well, the distance is x minus 5 squared plus y minus 0 squared, square root of that. So this is the distance formula. So if you want to minimize the distance, it is enough to minimize under the square root. And that would make our life a little bit easier. So we will minimize what is underneath the square root. So we'll minimize f of xy equals x minus 5 squared plus y squared, given the other condition, which is g of xy equals 4x squared plus 9y squared equals 36. So given this, we want to minimize that. So what do we do? We will look at the partials, set them equal to lambda equals the other one, and then we solve. So this is the Lagrange multipliers method. So gradient of f is 2 times x minus 5, 2 times y. So that's gradient of f. That would have to be lambda times gradient of g, which is 8x and 18y. And then the condition is 4x squared plus 9y squared equals 36. So we'll have to solve this system. We'll start from the easier one. The easier one is this one, 2y times 1 minus 9 lambda equals 0. So that would give us y equals 0 or lambda equals 1/9. So there are two cases. Case 1 is y equals 0. If y equals 0, from this star, from the third equation, we would get 4x squared equals 36, and that would give us x equals plus or minus 3. So we got 2 points. We got plus or minus 3, 0. We'll have to evaluate f of 3, 0. F of 3, 0 is going to be f was 3 minus 5 squared plus 0 squared. So that's 4. And f of negative 3, 0, that would be negative 3 minus 5 squared plus 0 squared. So that's 64. The second case is if lambda is 2, is 1/9. If lambda is 1/9, we'll take that and plug it into the first equation. We would get 2 times x minus 5 equals, and then we get 8 over 9 times x. So we'll clear the denominator. We get 18x minus 90 equals 8x, and that would give us 10x equals 90, which means x is 9. Now we're going to plug that into the third equation. Again, I called that star to see what we get for y. We get 4 times 9 squared plus 9y squared equals 36. And this is clearly not possible because this guy is too large. This gives you 9y squared equals something negative. Equals 36 minus 4 times 81, which is negative. So this is impossible. Which means the answer for the minimum is 4, and for maximum it is 64. But remember that this was the square of the distance, so we have to take the square roots. So the minimum distance is 2, and the maximum distance is square root of 64, which is 8. Okay, so I will see you in the next video.